Assalamualaikum. Di sini saya ada satu kertas peperiksaan percubaan SPM 2011 untuk negeri Johor tahun lepas ya. Ini kertas satu. Mari kita tengok macam mana nak menyelesaikan masalah-masalah untuk soalan percubaan ya. Saya harap apa yang dipaparkan di sini dapat membantu pelajar SPM insya-Allah. Mari kita tengok soalan yang pertama. Okay, soalan pertama. In diagram 1, set Q shows the images of certain elements of set P. State the type of relation between set P and Q. Okay, I think you are very well aware of, if you have studied maths, add maths, then you know there are 4 types of relationship, which is let me get it written down. One to one, that is one to many, yeah, many to one, and there's also many to many. Alright, so in this case we have for example an element in 4 in x, in set x, at number 4, and minus 4 is pointing to one image. 2 objects in x is pointing to one image in fx group, and 2 as well here, number 3 and minus 3, 2 objects is pointing to one image in set q. So this definitely is many to one. Right, so A, the answer is many to one. Okay, now using the function notation, write a relation between set P and set Q. Okay, let's take a look at this. I need a place to write. It says in the relationship is that F4 is equal to 16, and then F negative 4 is also 16, F3 is 9, so F minus 3 is 9. Actually, by one look you know already what the relationship is, but to facilitate understanding, so I'm writing it down. You know that there's a pattern. So but this means that 4 squared is equal to 16, as well here negative 4 squared is also equal to 16, and here 3 squared equal to 9, and here minus 3 squared equal to 9. So what do you mean? What does it mean? That it means the function is f(x) is equal to x squared. So this is the answer. So if you get this answer exactly as this one, you get 2 marks. Let's move on to the next question. Given that function f(x) equal to modulus of 4x minus 1, find the values of x such that f(x) equal to 5. Alright, that is a complexity because there is a modulus sign there. So what do we need to do? Okay, then we know that fx can never be any less than 0, because it's modular for x minus 1. Then this will always be fx is always greater or more than 0 because of the modulus. For x minus 1, a modulus of 4x minus 1 is always greater than 0, greater or equal than 0. So it means that we need to find a certain range of x that will make it fx to become greater than 0. Okay, we have to remove that modulus sign there. So how do you want to do that? First of all, we need to find the value of x at the turn of 4x minus 1 become 0. So we say let for x minus 1 equal to 0, and that makes x equal to 1 over 4. Then we know that if there is this function that I put in red bracket, right? If x is greater than 1 over 4, then that equation in red bracket will become positive. If x is less than 1/4, then it will become negative. So what do we need to do? We need to build two separate functions by removing the modulus. Okay, I'm not having enough space here. Then f(x) is equal to, for x minus 1, if x is greater or equal than 1/4, and f(x) is equal to minus for x minus 1 if x is any lower than 1/4. Okay, I shall because my font is a little bit big, so I need to divide this space into 2. Okay, then if f(x) is equal to 5, then what is the value of x? Okay, I named this let me give a name to these two equations. While I'm running out of space, I can name this as equation 1 and this as equation 2. Okay, so from 1, fx is equal to 5, then 4x minus 1 is equal to 5. Then that will make x equal to 6 over 4, which is 3 over 2. Right? And from 2, minus 4x minus 1 is equal to 5. And that will make x equal to minus 1. Minus with minus become plus. So plus 1 when you transfer it to the right, then become minus. So 5 minus 1 become 4, and then you are and then become minus 4 over 4, which is minus 1. So the answer would be we need to find, right? So that is the real answer. fx is equal to 5 when x is 3 over 2 and x is minus 1. Okay, it looks awkward because we don't have enough space. Maybe I should try to use another piece of paper. So let's move on. I definitely need to use a different piece of paper this time. Number 3, given the function fx, fx equal to x minus 2 over 3 and gx equal to px plus 1 over 3, find f minus 1, okay, inverse function f with the argument of 5. Alright. Okay, there are actually two ways to do this for number A, question A. Let me just, before that, I want to transfer this question to a new piece of paper because I don't think I have enough space to be able to communicate effectively. Let me just do this for a while. As you can see, I probably take much longer than the permissible time for examination because this one will involve showing the steps on how to work on some mathematical problems. So let's paste it here, a new paper, a new sheet of paper. So I'm gonna work out on from this piece of paper. Okay, let's take a look at the available methods. There are two ways, as I mentioned earlier, to solve problem A. We need to find inverse function of f with the argument 5. there are long ways, there are short ways. Let me show you the longer ways first. Given that fx is equal to x minus 2 over 3, we want to find the function, inverse function of x. What is that, right? So let y equal to fx. Y is just a temporary placeholder to keep the variable, so that is easier to manage. Then y is x minus 2 over 3. What I'm going to show you is the way to how to get with inverse function of f. Then 3y is equal to x over 2, because we transfer the 3 over to the left hand side. And then we want to leave x on the left hand side and nothing else. Okay, then x is equal to 3y plus 2. This is the inverse function. Then this makes inverse function, I put y here first, equal to 3y plus 2. Okay, and then set substitute x for y. Then I've got inverse function of f x equal to 3x plus 2. Okay, so once we have got the inverse function for f, then we can find the value of f, inverse function f of 5. Then we just replace the value. 3, the x is 5 plus 2, and then it becomes 17. Okay, this is a longer way. That is shorter way. Let me just put it here. Alright, we know that f minus 1 inverse function f5, and 5 being the argument. So what we can do here is right away put down fx to become equal to 5. Okay, why? Okay, I'll explain later. So x minus 2 over 3 is equal to 5. So where did this come from? Okay, I can explain. Although this is a short method, but the explanation is probably a bit long, a bit lengthy. As you know, f, if you do a nested function, f on, now let me just do this, inverse function of fx. You put fx into the argument, this will come back to square 1, which is equal to x. Okay, we take a function fx, we put that as argument for the inverse function of f itself, so it becomes x. Right, so why am I saying that? Okay, let's put a placeholder again. Let y become fx, then f minus 1 of y is equal to x, right? So if you want to find f minus 1, 5, right? This means that y is equal to 5. Let me check if the video is running correctly. Yes, okay. Y is equal to 5. Then that means where's my ink? Okay, that means fx is actually equal to 5, and that's why I put down there x minus 2 over 3 equal to 5 here. Alright, I hope you get it. I'll just box it outside so that it doesn't confuse anybody. This is just an explanation as to how I get these two steps here. So then x minus 2 is equal to 15, then x is equal to 17. So you see, we have arrived at the same answer, right? Oh yeah, there's one more step that I have not shown here. The step is that, let me just rub off this line. Then because x is equal to 17, then we can say inverse function of 5 is equal to 17. Then how on earth did I get this? Okay, let me just show you at the side here. We have proven from here that fx inverse f of y is equal to x, and when y is equal to 5, then x is equal to 17. Then that means we just replace the value of y equal to 5 and x equal to 17. That's how we get here. That's how we get this answer. Alright? And let's stop for now. We'll continue problem number 4, the next one. Oh no, we still have b. Yeah, okay, let me just continue on. We still have b. I've forgotten about b. I'll try to keep the limit of the video's length to between 15 to 30 minutes. So after 15 minutes, I will stop and continue with a new video for the next set of questions. Alright, and next one, we want to find value of p. This question, the value of p is a function of f3 minus x into gx. So let's do that. Let me just write that before I lost it. B f3 minus x equal to gx. And g is px. G is px plus 1 over 3. Gx is equal to px plus 1 over 3, and fx is equal to x minus 2 over 3. Okay, so let's put 3 over x into the argument here. So f 3 over x is equal to 3 over x. This is in place of x here. Okay, and then minus 2 equal to 3. Okay, and as such 3 over x minus 2 over 3 is equal to px plus 1/3. Alright then, so let's solve the one above first. And this means 3 minus 2 is 1, minus x is equal to, let's move 3 to the other side. This 3, let's move it to the other side, and it become 3px plus 1. And then we move. Oh no, move 1 and 1 over here cancel each other. Okay, as such x is equal to minus 3px. We want, but we want to find the value of p, right? Okay, I made a wrong move just now. Let's forget about this step, shall we? Forget about this step. Let's just do this. I just switch place. 3px equal to minus x, and then we can bring 3 and x over to the right. What will happen? Then p is equal to minus 1 over 3, because x and x actually cancel each other. X and x cancel each other, so p is equal to minus 1 over 3. Okay, that concludes the first part of the video. We'll meet again in part 2, where I shall answer question number 4 and beyond. Okay, see you.